Hi everyone, I hope you're all doing well. So, welcome to today's session where I am looking at just a few questions from Learning Unit 7. So, Learning Unit 7 is a section called Sampling Distributions. You are either working with a mean or a proportion for this section. You will be able to identify that from the questions itself, where if you're working with a mean, you will see that they literally say to you the mean or the average. They'll use those words specifically. And if they're working with a proportion, then you are looking for a percentage that's given to you, or they would say to you so many out of so many, or 1 in 10, that kind of thing. So it'll be so many out of, I actually wrote that incorrectly. So many out of that kind of thing. So you'll basically be given a fraction that can be converted into a decimal or percentage. So this is how you'll identify if you're working with a mean or proportion. And then in terms of the steps involved, they're the three that you see written at the top of the screen. So you'll see that with your sampling distributions, the same steps are followed regardless of whether you're working with a mean or a proportion. You will first determine the rule. You'll see that's done through drawing up a bell-shaped curve. This is what they mean when they say in a question that the data set is normally distributed. So the moment you see those words normally distributed, it's immediately saying to you you're working with a sampling distribution and you are drawing up the bell-shaped curve to identify the rule that is being followed. So that's drawing up the bell-shaped curve in question 1 to identify the rule. Then in step 1, not question 1. Then in step 2, you're going to calculate the value of Z. You'll see that under the mean, the Z value is calculated as X bar minus mu over the standard deviation over the root of n. And then under a proportion, the Z value is calculated as P minus pi over the root of pi multiplied by 1 minus pi over n. So there's two different Z values that can be calculated depending on whether you're working with a mean or proportion. Then once you have that Z value, still in step 2, you're going to go to the next step, which is to go to table 1 of your appendix. You'll see that it will be provided to you in your exam. I'm going to quickly just project it to show that to you. This is also at the end of your textbook. So if you skip to the back of your textbook and look at the appendix, the first table in your appendix is table 1 that we need for this learning unit. So this is what it will look like in your textbook. It should look more or less the same in your exam, in your formula sheet. This is actually a copy of the formula sheet. So it should be pretty much exactly the same. So then you have the table will be given to you. You do not need to know any of the values on this table. And the next, sorry, part of step 2 still is once you have the Z value from that table, you'll be able to determine your probabilities. And then in step 3, the last step, you're going to apply whatever rule had been determined in step 1, whether we say that it's the addition rule, the subtraction rule, whether it's the zero point 0.5 plus or minus rule. You'll see, I'll explain to you just now what those are. You will apply that rule in the last step. So back to what we see here, I'm actually going to just show you the bell-shaped curve first, and then once we have the bell-shaped curve, I'm going to start with the first question. So when you have step 1, your bell-shaped curve, you're going to draw up a bell-shaped diagram. Remember, this is just, and I can't remember whether I said that to you just now, but this is something that is not actually for marks, but we're drawing it up because it is extremely useful in assisting you in identifying what the rule is and how it should be carried out. So there's no actual marks, but you'll be able to visualize from this and see that this is the specific rule that we need to carry out, and this is in which direction we're moving, and that kind of thing. It's extremely useful. So I do suggest you carry out the step just for your own purposes so that you're able to see, visualize what the rule is and apply it accordingly. So when you draw up this bell-shaped curve, this is what it looks like. Down the center, you're drawing a straight line. Exactly 50% of data lies on either side of that straight line. So another way of saying 50% is as a decimal, you can say 0.5. And if you find that your value, and you'll see it become clearer when we do an actual example. If you find that the value that you are interpreting is falling on the right hand side, and it says, for instance, at least. So at least means that this is the smallest value, is the minimum, and it's greater than that. So let's just suppose hypothetically in a question it said at least 20. So 20 would be here, and at least 20 means 20 and everything above it. So you're moving in this direction. This line that you see at the bottom here is treated as a normal number line where it increases towards the right and it decreases to the left. So here, if it's at least 20, 20 is the minimum and it's everything greater than it. So it's everything towards the right. If you find that that is the case, then the rule is 0.5 minus. So basically, if you're moving away from the central line, then it is 0.5 minus. The same if you found that a value falls here. Let's say the value was 13 and they said less than 13, then that would mean that you're moving in this direction, which is away from the central line. Your rule would also be 0.5 minus. However, if you find that they change those words around, let's just say that they said to you less than 20. So if the question said less than 20 dot dot dot, this is just hypothetical to show you how that bell-shaped curve would work. Less than 20 means you're moving from this direction further to the left. So in that case, if you're moving towards the central line, it's 0.5 plus. And if they said more than 20 or more than 13 or at least 13, then it more means that 13 is the minimum and you're moving in this direction. So that would mean you are moving towards the central line and your rule would be 0.5 plus as well. So to redraw that diagram a bit clearly without actual values everywhere, I'm going to indicate that to you here. So without the numbers 13 and 20 and so on that diagram, you're going to see that if you're moving away from the central line, it's 0.5 minus in either direction. So as long as you're moving away from the central line, it's 0.5 minus. If you're moving towards the central line in either direction, it's 0.5 plus. In either direction, it's 0.5 plus. If you find that there's a value on the left and there's a value on the right, and they say between those two values, and let's just say they said this in the center was 20, this was 16, that was 23. So if you're looking at between those two values, and you'll see there are questions like here it says between, I'm just going to highlight that. Here it says between, here it says between again in the next question as well, and so on. If it's between two values and you find that each one of those values fall on either side of that central line, then it's going to be the addition rule, meaning you're not going to worry about the 0.5 plus. So you're not going to worry about this or this or this or this. And if you find that you're doing two values where both of them fall on the same side, so maybe they're both on the left-hand side or they're both on the right-hand side, then it is the subtraction rule. Okay, so this will become clearer once we start to work with the questions. So I am going to just erase this for now so that we can start working with the questions, and then you'll see it'll become clearer once we start to answer them. So the first question said to you that Glasshouse's PTY has found that the cost of fitting new windows is normally distributed with an average cost per window of 9750. So I'm going to highlight the key point here. They said to you it's normally distributed, which means we're drawing up your bell-shaped curve. They mentioned the word average, which means we're working with a mean, and they gave you the average of 9750. So immediately from this, I'm going to now start with part of step one, which is now to draw up your bell-shaped curve down the center. And again, this is not for marks, it's just to help you identify the rule. Down the center, that mean that they gave to you is your population mean. So this is your population mean. And remember I said to you, you're either working with a mean or an average, and they will mention those words specifically, and that will help you to identify that you're working with a mean, or they'll use the words percentage, or they'll say so many out of so many, and that will tell you that you're working with a proportion. So it'll be so many out of so many. Then you will find that the formula for your average, we said, is x bar minus mu over your standard deviation over the root of n. Under a proportion, your z value is calculated as p minus pi over the root of pi multiplied by 1 minus pi over n. So now we have your mean that we're working with. So we're working with the content on this side of that line. So here we have your population mean, which is mu, given to you as 9750. And then they say to you, and I'm going to actually write that in the center here instead of the symbol mu, 9750. And then they say that the standard deviation is 995. A sample of 95 windows, so n is equal to 95. A sample of 95 windows is randomly selected, assuming a normal distribution, and the first question said to you, determine the standard error for the sample. So the standard error is calculated as what you see in the denominator here. It's the standard deviation over the root of n. So the standard deviation they said to you was 995. The n value was 95. So it's 995 divided by the root of 95, which is 102.8, but sorry, 0.08. But because it's in rand values, we'll leave it as a rand value. So 102.08. Then the next question said to you, what is the probability that the average cost of fitting the windows in the sample is less than 9,500? So the key word to pay attention to here is less than, and the 9,500 is now your X bar. So you have everything necessary to now start with the actual steps that you see up here. So we started by drawing up the bell-shaped curve, and we put down the population value down the center. Now we need to put in the sample value, which is 9,500, and that should be, because this follows a normal number line, which increases to the right and decreases to the left. Remember, it's like a normal number line where it starts at 0, then it increases 1, 2, 3, 4, 5, and so on to the right, and then it decreases on the left to negative numbers. So it would be your normal number line. So here you would have numbers. So it would be your normal number line. So here you would find that the smaller number, the 95, should be somewhere on the left. And they're saying the probability that it will be less than. So less than means we're moving away. So you're moving left, more left, you're moving away from the central value. And if you're moving away from the central value, then from that central line, then it's a 0.5 minus rule. So here we know the rule. We've done question one, or step one, sorry. Then you have step two, which is to determine the Z value. So your Z value is calculated using the formula that I had written up here. This is because we're working with the mean. So it's X bar minus mu over the standard deviation over the root of n. So X bar is the 9,500. Ignore the words less than when you are actually calculating Z. You'll use just the number. So 95 minus mu is the 9750. And then it's over, the standard deviation is 995 over the root of n, which is 95. So that gives you a value of minus 2.45. So minus 2.45. And once you have that Z value, it says to you, and I'm going to highlight that again, go to the appendix table 1 and you're going to determine your probability. So the value is minus 2.45. Please bear that in mind because we're now going to go to table 1 of your appendix and we're going to determine what the respective probability is if your Z value is minus 2.45. So here is your table. We said that Z is equal to minus 2.45. Now, for the purpose of this module and in general, when it comes to this section, whether you're doing it in stats or any other module, you will always ignore the subtraction sign if you have a negative value of Z and you're going to read it as 2.45. That's because this table only has positive values. It doesn't have negative values. So it'll be 2.45. The first two digits, so the 2.4, that you're going to locate going down the first column. So if you look at down the first column, 2.4 is here. Then the last digit, which is 5, there'll always be a 0.0 before the last digit, no matter what the number is that you're locating. So that would be 0.05. So now you're going to look for that going across at the top. So you look for 0.05 and here it is here. So now in line with 0.05 and in line with 2.4, here's the value here. 0.49, sorry, I highlighted the wrong one. So in line with 2.4 and 0.9, the value is here, 0.49286. So the respective probability is 0.49286. This is the probability that we need. So we're going to take that 0.49286 to our question and then apply the rule. So I'm going to write down here again that same value that we determined from the table, 0.49286, and you will literally say P is equal to 0.49286. Now we can apply the rule in step 3, and you're going to say, and I'm just going to erase here so I have some space to write. Now you're going to say that the rule we had identified in step 1, here it is here, I'm highlighting it in yellow, was 0.5. So you're going to say that the probability of your value being less than 95 is calculated as 0.5 minus this value that you now got from the table, 0.49286. So because it was a 0.5 minus rule, we determine the probability and we say 0.5 minus that figure. So that's 0.00714, which as a percentage is 0.714%. So to answer the question, simply plug in that answer that you just calculated into the question and let it read as a closing statement. So you'll say there's a 0.714% probability that the average cost of fitting the windows in the sample is less than 9,500 Rand. And that would be your answer for number 1. Okay, so let's look at number 2 now. So exactly the same 3 steps, it's just a little bit different wording. So here in question 2, they said to you the marks obtained on a Maths Olympiad test are normally distributed. So again, the fact that they mentioned normally distributed means that in step 1, you're going to draw up your bell-shaped curve. And then they said to you, you're going to draw up your bell-shaped curve. And then they said to you, it's with an average score of 87. So that average goes down the center. Here's 87 here. That's your population value. And a standard deviation of 9.75. What is the probability that a randomly selected person will? So what's important here is that they said a randomly selected person, meaning that n is equal to 1. Then they said to you, what's the probability that that randomly selected person will obtain a score between 88 and 90 and interpret your answer? So here, the first thing you're going to do is continue with this bell-shaped curve. You're going to have 2 values here because they said between 88 and 90. You're going to plot both 88 and 90. So 88 should fall somewhere to the right, which is here, and 90 would also be on the right-hand side. And as you can see, these are 2 values which are both on one side. This would mean that the subtraction rule is applied. So when we say subtraction rule, what that means is we need to now, we've identified the rule in step 1. We need to now in step 2 calculate 2 separate Z values because we have 2 separate X values. The 88 is one X value, 90 is also another X value. So you're going to say in the formula, remember the formula says x bar minus mu over the standard deviation over the root of n. We're going to now say that it is the first time around x is 88. So it's 88 minus your mu is the 87. That's from the initial information. Here it is here. Then it's over the standard deviation, which is 9.75, over n, which is 1. Sorry, over the root of n, which is 1, the root of 1. Then the second time around, you're going to do exactly the same calculation, except for now you're going to make x bar 90. So it'll say 90 minus your mu of 87 over 9.75 over the root of 1. So this would be 0.1 on the left-hand side and 0.31 on the right-hand side. Now you're going to do exactly as you had done. Go to table 1 of your appendix and determine a value for P. You're going to determine 2 separate P values because you have 2 separate Z values. So from the table, you have 0.10 that you need to look for, and then you also have 0.31. So here's your table. Let me just erase what's here. Okay, so one Z value was 0.1. We'll determine its respective p-value. And then the other Z value, I'll write that at the bottom, was 0.31, and we'll determine its respective p-value. So 0.10. The 0.1 you're going to locate coming down the first column. So here it is here. Let me change the color. So 0.1. And then the 0, the last digit here, there's always a 0.0 ahead of it. So 0.0 and then 0 again, that's here. So in line with that 0.1 and the 0.00, remember you're literally just doing this. You're saying in line with that, in line with this is the value here. So 0.0398, 0.0398, and then here at the bottom, you're looking for 0.3 coming down the first column. So that's here. And then the last digit will have a 0.0 ahead of it. So it'll be 0.0 and then the 1. So in line with 0.3 and 0.01, you have 0.1217. So now you can write that down, 0.1217. And now you have two different p-values which you're going to take back to the question. So now you can say that for the value of the first one where, sorry, just want to write here. Okay, so for the first one where you had Z is 0.1, that gave you 0.0398. And then when Z was 0.31, that gave you 0.1217. So now that you have your respective 17. So now that you have your respective p-values from the table, all you're going to do is apply the rule. And the rule, we said originally at the beginning, the rule is that it's minus. So what this means is you're going to take the higher number of the two p-values. So the higher between the two p-values is the 0.1217. It's always the higher number minus the lower number. So it's going to be the probability is equal to 0.1217 minus the smaller number now is the 0.0398. And that gives you 0.0819, which is equivalent to 8.19%. Okay, so to answer the question, you will say that there is an 8.19% probability that a randomly selected person will obtain a score between 88 and 90. Okay, so this is when you did the rule where they are between two numbers, but both of them are on one side. Let's look at now where the values are on either side and not just on one side. So I'm going to clear whatever's on the screen. Okay, so now they're saying to you, what's the probability that, so what is the probability that a randomly selected person, so again, n is equal to 1 because it's one randomly selected person, will obtain a score between 84 and 91. So if you draw up your bell-shaped curve again, down the center is that central value of 87 that was given to you. 84 is your first X bar. 91 is your second X bar. 84 would be somewhere on the left. 91 would be somewhere on the right. Now you see that these two values are on either side of that central line. So in this case, instead of subtraction, it would be addition. So exactly the same process. You're going to say Z is equal to, calculate two separate Z values. So the first time around, Z would equal to X bar of 84 minus 87 is mu over your standard deviation is 9.75 over the root of 1. Then the second time around, 91 will be your X bar minus 87 over 9.75 over the root of 1. And that would give you the first one on the left. That would be 0. Sorry, I'm just trying to find that page. Okay, I actually need to calculate it because I can't locate that page. Okay, let me calculate that for you. So that would be 84 minus 87 over 9.75 of the root of 1, and that is minus 0.31. And then it's 91 minus 87 over 9.75, and that's 0.41. Okay, so now that you have those values, again, all you're going to do is go to the table. So in the table table 1, you're going to locate minus 0.31 is a negative, but you'll ignore the negative sign. So it'll be 0.31 and then 0.41. So let's locate that. Okay, let me clear this. So the first one is Z is equal to minus 0.31, but again, we ignore the negative sign. And then you have Z is equal to 0.41. So here, 0.3 is located down the first column. So here, 0.3. And then you have 1 as the last digit here. So it's a 0.0 first and then the 1. So 0.01 in line with that. It's 0. So in line with, remember, here, in line with here and here. So 0.1217 is the first one. I'm going to write that here. P is equal to 0.1217. And then here 0.41. So 0.4 is located going down the first column. So that's just below the one we were working with. And then in line with 0.01, the 1. So that's here. So in line with those two, it's 0.1591. Okay, so we are going to take those p-values back to the question, and you're going to say then that, sorry, I'm just trying to project the question. Okay, so here you're going to say that from the information that we had been given, P is going to be 0.1217. P is going to be 0.1217. 0.1217 here and 0.1591 here. And now you're going to apply the rule which said to us, remember we had identified the rule is addition. So you're simply going to say the probability is equal to the sum, addition of both those probabilities individually. So 0.1217 plus the 0.1591. So 0.2808, which is equivalent to 28.08%. Okay, so that would be then interpreted as there is a 28.08% probability. So literally just look at the question and substitute your value so that it reads as a closing statement. So you'll say there's a 28.08% probability that a randomly selected person will obtain a score between 84 and 91. And that will be it for that one. Okay, so I'm actually just going to do one more, which is the next one, question 3, because then it's quite repetitive. It's more or less the same thing going forward. You're either applying the addition rule if it is on either side of the central line, if it's between two values, or if it is between two values and they're on the same side, then it's going to be the subtraction rule. Or if it is just one value and you're saying at least, at most, greater than, less than, then it's the 0.5 rule. So that was for your mean. Let's look at the last one now for your proportions. So this says to you, and it's exactly the same step. The only difference is you are working with a proportion instead of a mean. So with the proportion, the formula is P minus pi. For z, it's p minus pi over the root of pi multiplied by 1 minus pi over n. Okay, so that whole thing, I'm just going to leave it at the top here so we know the formula. Let's identify and highlight what the actual values are. So it says to you, Glasshouses Pty Limited has found that 23% of its customers live in the Cape Town area. So that 23% is your value of pi, which we will convert to a decimal, so it'll be 0.23. Then they say to you, a sample of 155 customers is randomly selected. That would be n. So n is equal to 155. Assuming normal distribution. So again, the fact that they said to you that this is a normal distribution means that you're going to draw up your bell-shaped curve. Down the center is your population value, which is the 0.23. And then we're going to determine the rule in a minute. So the first question said to you, determine the standard error of the or for the sample. So the standard error when it comes to your proportion is actually the denominator of this formula as well. It is the one that says the root of pi multiplied by 1 minus pi over n. So in this instance, it's going to be pi is 0.23, so it'll be 0.23 multiplied by 1 minus 0.23 over n, which is 155. So this is going to give you a value of 0.03. And that's question 1. Then the next one says to you, what is the probability that more than 24% of the customers in the sample live in the Cape Town area, and interpret your answer. So that 24% itself is your P value, and they're saying more than 24%. So when you plot this onto your diagram at the top, 24% as a decimal is, so I'm going to say here, P is 0.24 as a decimal. So that's 0.24, and they're saying more than. So it's going to be moving in this direction. And as long as you're moving away from the central line, it would be 0.5 minus. So we now know the rule that needs to be applied. We can go on to step 2. So that was step 1. Step 2 is now to determine your Z value. So it's the formula that I wrote out here. It's P, which is 0.24, minus pi, which is 0.23, over the root of pi multiplied by 1 minus pi over n, which is 155. So this gives you a value of 0.3 as your Z value. The next step is exactly the same as well. You'll take the 0.3, you will go to your value. The next step is exactly the same as well. You'll take the 0.3, you will go to your formula sheet or your appendix table 1, and you will determine what the respective probability is for 0.3. So Z is equal to 0.3. You're going to look for the first 2 digits down the first column. So here is 0.3, and the 0, which is here, there'll be a 0.0 ahead of it. So it'll be 0.00. So here it is here. So in line with that 0.3 and the 000, it'll be 0.1179. So now we can take that, P is equal to 0.1179. We will now take the 0.1179 back to the question, and we're going to apply the rule. So here you're going to say P is equal to 0.1179. So your final answer, which is the probability of your value being greater than, more than 24%, is equal to, we said the rule was this at the top, 0.5 minus. So it'll be 0.5 minus 0.1179. So that would be 0.3821, which is 38.21%. So here to interpret this, you will literally take that into your answer, into your question, and let it read as a closing statement. So you will then say there is a 38.21% probability that more than 24% of the customers in the Cape Town, more than 24% of the customers in the sample live in the Cape Town area. Okay, so I'm actually going to stop there for today. Sorry about that. I know I took up a bit of your time, but please can I ask that you have a look at the question at the bottom, the last one that you see here. Practice these questions, try them out without me having to without you listening to the answers. Maybe just have a look at what's up on the screen with a blank screen. So I'm just going to clear that and show you. So try this out as you see it without having a look at the answers. Get a feel for it. Look at the table 1 of your appendix. I am going to upload more videos for you. I'm also going to upload more revision worksheets for you so you can try out more examples of these as well. Please listen in on the other additional videos as well and try out the examples so that you can practice more. And I will chat to you again soon. Thank you, everyone. Enjoy the rest of your evening.